Hello, this is the SpeedyCat project by Ethan Zeltinger and Joran Oien, myself. This is for ECE 376 embedded systems. Today we're going to be asking the question, how fast does Freya chase after a laser, which is my cat? And we're going to be, in order to answer that question, we're going to use a 90% confidence interval. There's our hypothesis, and to go over our hardware and how it works, I will give it to Ethan.
Alright, so here's our hardware setup. Simply the ultrasonic sensor on a breadboard, and we just attach it with wires to 5 volts and ground, and then the trigger is RC0 here, triggering every 0.1 seconds, and then RC2 is hooked up to timer 1 capture. So it's capturing the distance, and then the distance is being recorded twice, and then we divide it by 0.1 seconds. So the change in the interval of time that the distances are being recorded. And so then on the LCD, what's being displayed is the top speed in that recording session of miles per hour and meters per second, if you can see that there. So it won't start recording speed until I press RB0. So if we look at it from this angle here, I can press RB0 here, and I'll just put my hand right up next to the ultrasonic sensor, and it will be measuring speed. And as I go faster, it'll log a faster speed. And so there you can see it measured 3.41 meters per second, 1.52 miles per hour. And then also, as you can see, there's a lot of data that got logged on the GUI in the corner there. So I'll do one more demo here and see if I can get a faster speed here. So again, the LCD is only logging the top speed. So right now it's sending lots of zeros to the GUI there, and then as I move a little bit, there's a small speed, and then if I move really fast, then there, I got it up to 4.46 meters per second, and then R7 clears that and restarts the recording, clears the top speeds. So there's our hardware setup that we used to record the cat running at the laser.
So this is my cat Frey. She is about 2 years old now. This is her laser. She really likes her laser. She does like a little chirping whenever she sees it, and she's super playful. She also likes to seal out, I call it, like this. Spread the legs and just relax. It's one of her favorite things to do. Her other favorite thing to do, you'll see right here, is play tug-of-war with her string. Yeah, she really likes to do that for some reason. So she will be our experimentee in this experiment for our term project today. This is the hardware setup I'm going to be using. You can see how I have the rangefinder like in front, and then I can use the LCD display and look at it still, press the buttons, and it's going to record every 1/10 of a second. It sends out a pulse and comes back and gets a reading. I tried a couple different configurations, like every four times a second and 100 times a second, but 10 times a second seemed to work the best. I also, for a gauge, here you can see I have two salt and pepper shakers. This is a meter away, and then I recorded in slow motion to see how fast Freya ran across them. And we saw that it was about 2 meters per second that Freya ran, and that was at a slower speed, so we kind of knew the range that we'd be looking for. This is one of my better videos. It was like the only one that I recorded vertical, but she was so playful this day that This is one of the best ones, so you can see her running back and forth in front of it. And I'm recording. You can't really see the LCD, but and then I'm outputting to the computer. Here, you can see in the same play period, she got tired. She gets tired pretty fast sometimes. Other times she goes longer. Here is an example of her running after the string and outputting to the GUI. Now I'll let Ethan take it away for the data analysis.
Data analysis that we did for the running cat. Here's our unfiltered data that was recorded with the ultrasonic sensor. As you can see, there's negative and positive values in here and indicating velocity, and there's also some really kind of crazy values like 25 meters per second or 98 meters per second, and those are going to be when the ultrasonic sensor misses and jumps from the wall to the cat or the cat to the wall. So what I did here is just filtered out that data down to the range of speeds that we knew the cat was probably going, between 1.25 and 4 meters per second. And we also took the absolute value of that just to convert it to speed from velocity, because we don't necessarily care about the velocity, the direction it's going. We care more about the speed. So I used that data to find the mean, the standard deviation, and the degrees of freedom. And then from there, used that data to get some t-scores from StatTrek. These are the t-scores that I got for 5% and 95% so that I could make a 90% confidence interval. So 90% of the time the cat is going between the speeds of 0.63 meters per second and 3.7862 meters per second. So then we were able to plot that data out here, and on the left here you can see the filtered out data. We didn't necessarily care about per run data chasing the laser, but instead we just mashed it all together kind of, and we just wanted to know on average the speed that the cat was going. And so here's the probability density function for the cat running after the laser, and the gray area here marks out the 90% confidence interval, going between 0.63 and 3.78 again. So there's our data analysis.
In conclusion, we can use a 90% confidence interval to answer the question, how fast does Freya run after the laser on average? We can use the range 0.6343 meters per second to 3.7862 meters per second to answer this question of how fast Freya runs after the laser on average. If we wanted to know her top speed, we could use one of the numbers from this graph of the unfiltered in the range from 1.25 to 4. That's about 3.85, 3.9 meters per second would be her absolute top speed. This has been Ethan Zeltinger's and Joran Oien's Embedded Systems Term Project.